Right, I hope you can all see that. So I'm General Manager External Affairs for Anglo American's crop nutrients business, and I've been involved in the project for about 9 years now. So that's well in excess of the time that Anglo American have been involved. So it's been a really exciting journey. And I want to start off by just touching upon the takeover. So as I'm sure most of you picked up at the time, we announced back in September last year that we couldn't deliver our stage 2 financing due to very uncertain and unfavourable conditions in the global bond markets. So we slowed down the project and we looked for alternative options. So there's an extensive global search, and that culminated in an offer by Anglo American to buy Sirius Minerals outright. That was the deal on the table, and it was the only viable way forward. And that was completed in March this year, a week before the lockdown. So whilst we were disappointed that we couldn't bring it into production ourselves after 10 years of hard work, and it wasn't the outcome that we set out to achieve, it was the only viable way forward. And Anglo American has the financial and technical capability to make sure that the project gets built and that the benefits it will bring to the region are delivered. So a brief introduction to Anglo American. So Anglo, we are one of the world's largest mining companies, headquartered in London, on the FTSE 100, and globally we employ over 100,000 people. So you can see on this map here, we've got 35 projects and mining assets, and you can see them listed by the different business units that are within the Anglo American group that are listed on the left there. So we are crop nutrients. So as you can see, the vast majority of the projects are in the southern hemisphere, with the exception of us. De Beers in Canada, and also there's a project, the Sakati project, in development in Finland. So one of the key reasons that Anglo American were interested in the Woodsmith project is that there's a real close fit with the group's strategy to move towards mining metals and minerals that support a growing population and a more sustainable world. So it really fits in with that sustainability agenda. So just to add to that, we, Anglo American, are looking at phasing out thermal coal within the next 5 years. So the Anglo American purpose, as you can see there, to reimagine mining to improve people's lives, really reflects this approach. So by reimagining mining, that's more innovative technology and data-driven mining methods that are safe, efficient and sustainable. And the improving people's lives bit is not only in the application of the products and the stuff that we mine, but making an economic and social contribution to the areas that we operate in. So I'm just going to give a quick overview of the project now and give an update of where we're at with the different elements. And apologies to those of you who I'm sure have heard much of this before, but there's certainly a lot to update as we get further through the presentation. So a key driver for the project is global food security. So to put very simply, over the next 40 years and moving forwards, we need to get more food from less land. So the global population is set to increase by a third, increasing the demand for food production by 60%. And at the same time, the land available for farming is going to shrink by 15%. So that's global food security is one of the most pressing issues facing the world today. And fertilizers play an important part of addressing this issue. But the key element is fertilizing and using sustainable fertilizer practices. So large-scale agricultural practices have been responsible for a lot of environmental harm. So the over-application of fertilizers has led to soil degradation, deforestation, habitat loss, and then, of course, there's the impact of that on climate change. And what we think we can bring is a significant but yet sustainable contribution to global food security. So another thing, the second thing that's really underpinning the project is that we've identified the world's largest and highest grade polyhalite resource. So you can see the red shape there, that's our area of interest. So between 2012 and 2014, we drilled a number of boreholes. So 16 boreholes, over 17,000 meters worth of drilling to understand the extent of the resource. So the little dots that you can see on the map there, they're historical boreholes for oil and gas that were drilled from the 1930s onwards. So the geological records showed that there was polyhalite there. So what we did with our exploratory drilling campaign was we supplemented that information to make sure to see if there was a viable polyhalite resource to base the development of a new project upon. So, and what we found in the darker green shaded area around where the larger dots are, that's our very verified polyhalite resource, and there's 2.6 billion tons of polyhalite just within that area there. So we're going to be around a long time. So Poly4 is the trademark name for our polyhalite products. So put very simply, we extract the polyhalite from a mile beneath the surface. We grind it and crush it. Add a small amount of starch, and that creates the polyhalite granules. We've performed over 600 trials over the last few years, and that's on over 60 crops in 33 countries, and that has shown how effective polyhalite is as a multi-nutrient fertilizer, and it's suitable for widespread commercial use. So what's unique about polyhalite is that there's 4 of the 6 macronutrients that all crops need to grow together in one mineral. So as well as the potassium, you've got the magnesium, sulfur and calcium together with many other important micronutrients as well. And one thing that we are increasingly understanding is the positive environmental characteristics of Poly4. So it's the fact that for every ton of polyhalite ore that we mine is a ton of product. So there's no waste involved, and that helps to make sure that we've got a low carbon footprint. There's no chemical processing involved, and very importantly, the nutrient release profile of polyhalite. So it releases the nutrients when the plants need them rather than all at once. And that means that the nutrients are used and are not wasted, and there's not some of the problems that I talked about earlier associated with that occur. And also it's certified for organic use. So here's the development plan. So you can see on the left there's 2 shafts. There's the production shaft and the service shaft that are going to be sunk 1,600 meters into the seam of polyhalite. That's up to 70 meters thick in places, but has got an average seam of 25 meters. You can see at the tops of the shafts there, so that's called the 4 shafts. Obviously, this isn't to scale, but the tops there are wider than the main shaft. That's because we are sinking the winding gear into the 4 shafts that are 60 meters deep and 35 meters wide. That means that we don't have to have the big winding towers on surface in the national park. And as you can see there, the ore is mined with continuous miners. So that's a continuous miner that you can see on the right. It's cut away from the rock face and then hoisted up the production shaft to 360 meters below the surface, where it's loaded onto a conveyor belt in an underground tunnel that takes it 23 miles to Wilton International Site, where the granulation plant is. You'll see there that there's an intermediate shaft and that is at Lockwood Beck, and many of you may have driven past that. So the priorities in developing the project were low operational costs, high production capacity, and low environmental impact. So now I'm going to go through each element of the project and an update of where we are. So before we do that, that's the mine site before we started. So it was known as Dove's Nest Farm. So I keep meaning to draw a border on here so you can see the extent of our land, but it's the majority of what you can see on that slide is the site itself. So it's 104 hectares, and we are developing approximately half of that. So the reason for choosing this site, it's in the sweet spot of the geology. It offers a great amount of natural screening. As it is, you can see the trees there, and also there's only a handful of people that live in very close proximity to the site. If you go out to about a mile, there's probably about 60 households within a mile of the site itself. So that's what it looked like before we started, and that's what it's going to look like when we've finished. So everything that we're doing on the site to recognise its location in the national park is reducing the size of the buildings and the number of the buildings to an absolute minimum. And also with, I'm sure you can imagine, there's a great deal of excavated material to come out of the shafts that are a mile deep. So that is all retained on site, and that bunds are created around the site, and with additional planting, that means that the buildings cannot be seen from external viewpoints. So that's the end game in terms of the mine site. That's what we're aiming for, and that's what it looks like at the moment. So everything on there, bar one building, is temporary and just there for the duration of construction. So what you can see on the right, just in front of those white, I don't actually know what they're, those white sort of temporary buildings that you can see right at the front. Just in front of that, that's the service shaft. So that's the fore shaft of the service shaft. So you can see there, that's 35 meters deep and 35 meters wide and 60 meters deep. And then below that, the shaft goes right in diameter to about 8 meters, and that's currently at a depth of 120 meters. Underneath the building, like you can see the framework there, that's the production shaft, and that's also down to 120 meters depth. What you can see on the left there, that tower, that's a temporary winding tower. So there's a third shaft at the mine site, and that third shaft just goes down to 360 meters, and there'll be a cavern at the bottom of that. And the purpose of that shaft is that there's a tunnel boring machine will be launched from that end, in addition to the tunnel boring machine that's already been launched from the other end. So the shaft sinking is going to be done using shaft boring road headers. So essentially they are vertical shaft sinking machines, and you can see one here fully assembled at surface, and that was in Germany. On the right there, you can see a close-up of the cutting head. So at the moment, the first SBR has already been lowered into the production shaft. So that's suspended in the production shaft down to a depth of 120 meters, and that is ready to start cutting around the end of this year. And following that, very shortly after that, the SBR for the service shaft that is currently on site and it is currently being assembled, that will also go in the service shaft and start cutting as well. So the mineral transport system, so that's what we call the tunnel. So what you can see on the left there, and it's pretty unusual to see a tunnel boring machine fully assembled at surface, but that's what you can see there. So that was the launch ceremony that was held back in 2019, last April, and you can see some school children there. So we held a competition with local schools to name the TBM. And the little lad there with the blue jumper on, he won the competition and he chose the name Stella Rose. So Stella because it's the Latin for star, and Sirius is the brightest star in the sky, and Rose after Rosebery topping. So a really positive thing about the MTS is that we've made much faster progress than we'd anticipated. So we're now at 11 kilometres. We're ahead of schedule, and in October we did 1,000 metres, and over the last 10 weeks we've averaged 30 metres a day. And you can see the image there on the bottom right of the tunnel, and it's fully lined in precast concrete segments, reinforced concrete segments that are all produced at Wilton that I'll get onto. So that's the Lockwood Beck site. So that's the intermediate shaft. So because the plan was to launch another tunnel boring machine from Lockwood Beck towards the mine site, but because we're making such good progress, we're just going to carry on with Stella Rose. But we do still need a shaft there for ventilation purposes, but it doesn't have to be anything like a significant shaft as what we were proposing. So we're going to do that with a technique called blind boring, and there's a rig that's going to arrive on site shortly. So that's the Wilton site that you can see there. That's a 30-hectare site. So the buildings that you can see, everything that you can see sort of in the foreground there, that's all to support the construction of the mineral transport system. On the left there, the sort of flat earth that you can see there, that's where the materials handling facility, which is the granulation plant, that's where that's going to sit. So in the foreground, you can see the steel hall, and then just beyond that, the segment factory. So as I said, the tunnel is lined with precast concrete segments that are reinforced with steel cages that you can see there on the left. So we're going to need 150,000 of those segments that you can see, some of them on the bottom right there, and they are all going to be reinforced with these steel cages, and which you can see there. Interestingly, that you can see someone tack welding the rebar that comes in coils to create the cages. That we're now using robotics to do that, and that the steel hall, the processes in there are now fully automated. But importantly, we haven't lost anyone. We're just managing to produce more with less people. So that gives an idea of what the materials handling facility will look like. The granulation plant, the mined polyhalite comes out the tunnel, goes into that dome that you can see on the top right there, that has a capacity of 130,000 tons, and then it goes through a process of crushing, screening, granulating, drying, and then it's taken on an overland conveyor to the new port facility where it will be exported all over the world. This is our R&D plant. So this is basically the materials handling facility, but on a much, much smaller scale. And we've set that up, and it's in a warehouse on the LV shipping facility. And the purpose for that is to help us to optimize the processes and design for the NHF, to produce granules for crop trials and also for training. And there you can see an image of what the port facility will look like once we've finished. And on the bottom right there, that's as it is at the moment. And you can see that we're going to have large storage sheds on the old steelworks land adjacent to the berth. So final slide. we've already made a £600 million pound contribution to regional economy, and of course, an investment of this scale is naturally going to bring great benefits locally, regionally, and nationally. And you can see some of the big numbers here. But what we want to do is we want to maximise this as much as possible. So that's local employment. So around 2/3 of the workforce are employed locally at the moment. At the Wilton end, it's more like 75%. We want to build a local supply chain, and we want to attract investment to the area. So that's me. I don't think I've got time for questions, but I am going to be in the VIP area if anyone would like to join.
Excellent. Thank you very much, Matt. Yeah, I'm afraid there isn't time for questions. That was excellent presentation, really exciting project, and fascinating insight into that. If you want to talk to Matt, he should be within the VIP area, so you can go and see him, or you can message him after you find his name in the lobby area. So you can message him with questions, and he can answer those online for you. So thank you very much, and please come back for our next presentation, which is at 10:25 from Kim West at Renew ELP. So thanks again, Matt. That was great.
Thank you.